We have learned how to find local extrema and absolute extrema of functions, so now we're going to use this in application problems. Now, optimization problems in calculus can be a little tricky because you have to set up the equations. Sometimes, like you'll see in this video, the equations are given to you and then they can be a little bit easier to work with. So I'm going to do both kinds to kind of show you. So the first one is we're going to have to set up our problem ourselves with the given information. We want to find two numbers whose difference is 19 and whose product is a minimum. So we're trying to minimize the product. So first we need to assign variables because it's a word problem, it's important. I'm going to let x represent number 1 and I'm going to let y represent the second number. So their difference, x minus y, is going to be 19. And their product, which I don't know what it is going to be a minimum. So I'm going to let p be equal to x times y. So I need to minimize this little guy. But to minimize, I need to take the derivative, I need to find the critical numbers, and so far, I can't take the derivative of this because it's x and y. So what I'm going to do is you use this part to create a function of only x's or y's, and then you plug it into the product. So either I can solve for y and plug it in, or I can solve for x. In this situation, I would solve for x because it's easier to bring the y over. So I'm going to take this and replace it with the x here. So I'm going to have p is equal to 19 plus y times y. And now I have a function of only y, so I can take the derivative. So before I take the derivative, I'm going to distribute the y. And now I just need to use the power rule. So p prime will be 19 plus 2y. I'm going to set it equal to 0 to find my critical numbers. It's never undefined. So I'm going to have 2y is equal to negative 19, which means that y is equal to negative 9.5. Now I have to check that this is a minimum because it could easily be a maximum and we don't want that. So there are two ways to check. You can use the first derivative test by creating a chart, or the second derivative test. I like here to use the second derivative test. So when I do this, it's going to give a positive 2. So when I plug in a negative 9.5, it's still going to be 2, which is greater than 0, and by the second derivative test, that means that this is a minimum. So I have the correct minimum at negative 9.5. Now I still need x, so what I do is I plug back in my y here to solve for x. So it's going to give me x is equal to 19 minus 9.5, which will give me a positive 9.5. So my two numbers are 9.5 and negative 9.5. Let's look at a different type of question. Still optimizing, so maximizing or minimizing. A company manufactures and sells X headphones per week. The weekly price, demand, and cost equations are respectively. And so now here they give us the equations, which I think makes the question a little bit easier. Part A, what price should the company charge for the cameras and how many cameras should be produced to maximize the weekly revenue? What is the maximum revenue? So that's the key here. We're maximizing revenue. So first I need a revenue function. So I have R of X is going to be X times P of X, which is going to give me 400x minus 0.5x squared. So I need to maximize this, so I need to find the critical numbers, so I need the derivative. R prime of x is going to give me 400 minus 0.5 times 2 is 1, so there will just be minus x. I set this equal to 0, and I get x is equal to 400. But again, make sure that you check that this is a maximum and not a minimum. So I will find the second derivative, which will give me a negative 1. But when I plug in 400, this is still negative 1 because there's no x, and this is less than 0, so by the second derivative test, this is a maximum. So I know I need to sell 400 cameras. Go back to what the question was asked. It said, what price should the company charge? So I need to get the price, so I have P is equal to 400 minus 0.5 times 400, which is going to give me $200. So I need to sell $200 per headphone. And when I do that, my maximum revenue, R of 400, is going to give me 400 times 400 minus 0.5 times 400 squared, and that's going to give me $80,000. So I need to sell 400 cameras at $200 a piece to make a revenue of $80,000, my maximum revenue. Okay, part B. What is the maximum weekly profit? Okay, so now we're trying to maximize profit. So we don't have the profit function, but we can easily find it because we know that profit is revenue minus cost, which I have both of. So I have 400x minus 0.5x squared minus my cost, which was 2,000, plus 200x. I'll distribute the negative, so that will give me a negative 2,000 minus 200x. And when I combine like terms, that will give me 200x minus 0.5x squared minus 2,000. So I need to maximize this, which means I need to find the critical numbers. So I have p prime of x is equal to 200 minus x. I set this equal to 0. I get x is equal to 200. Now I need to check that this is a maximum. So I'm going to use the second derivative test. So p double prime of x is going to be negative 1. And when I plug in 200, it's still negative 1, so it's less than 0, so it's a max. Awesome. But be careful because it asks you for what is the maximum profit, not the maximum amount of cameras. So you still need to plug in 200 into your p function, which would be this little guy right here. And when you do that, you're going to get $18,000. So you're actually making a bigger profit with less cameras than you are when you're selling more cameras. That could be maybe your cost function is increasing too large when you're making more. Let's do one more. A cafe sells 750 wraps per day at a price of $7 each. A market survey shows that for every 20 cents reduction in price, 30 more sandwiches will be sold. How much should the deli charge for a sandwich in order to maximize revenue? So this one's a little tricky to set up the function, so I'm really going to take it slowly here. First, I'm going to look at the current situation. So currently my revenue is that I'm selling 750 wraps at $7 each. So I'm making this much money, 750 times 7. Now, I know that for every 20 cents reduction, I'm selling 30 more sandwiches. So if I was to reduce by 20 cents only, I would sell exactly 30 more. So I would reduce it by 20 cents, which would be $6.80, and I would sell 780 sandwiches. But I could keep doing this. So I would sell 30 and then I would sell another 30 if I reduce it by 20 cents again. And I could keep doing. So then I would sell an extra 30 if I reduce it by again 20 cents. So let's look at what's changing here, right? So in this case, I only added 130 because I'm reducing it only by 120 cents. Here, I'm adding 2 30s because I'm reducing it 20 cents twice. Here, I'm adding 3 30s because I reduced it by 20 cents 3 times. So what's changing on the first part is changing in the second part. So if I was to add 4 30s, I would reduce by 4 20 cents. So what I'm creating here, and I'll write it one more time, I have 750 plus 30 times 1, 7 minus 20 cents times 1. Here I would have 750 plus 30 times 2 times 7 minus 20 cents times 2. So I can create a function, r of x, where I have 750 plus 30x times 7 minus 20 cents x, where x is the amount of 20 cents reductions I'm doing, or the amount of 30 sandwiches that I'm adding to 750. But now that I have a function, I can maximize this by taking the derivative and finding the extrema. So before I do that, I'm going to FOIL because otherwise I'm going to have to use the product rule, which isn't bad, but I prefer to FOIL out when the powers are 1 here. It's easy. So I'm going to have 750 times 7, which is going to give me 5,250, plus 210x. 20 times 750 is going to give me 150x negative, and 20 cents times 3 is going to give me 6x squared. So now I can easily take the derivative, so that's going to go to 0. That's going to give me 210 minus 150 minus 12x. I'll combine like terms, which will give me 60 minus 12x. I'll set it equal to 0. I'll get 12x is equal to 60, which means that x is equal to 5. Again, I do want to double check that my this is a max. So this time I'll do the first derivative to remind you. The first derivative test is you put the 5 here. 0 would be over here, because remember that you can't, right, do a negative amount of reductions. So here I'll pick 1, here I'll pick 6, and when I put in 1, I get a positive number, and when I put in 6, I get a negative number. So this is a max. So that's the first derivative test. But it did ask you, how much should the deli charge? So 5 was the amount of 20 cents reductions I was doing. So if I'm doing 5 20 cents reductions from 7, I'll have 5 minus 0.205. But 5 20 cents is $1. So I have 7 minus 1. So I'm going to be selling my wraps for $6 a piece.